This is the indoor unit of the LG ArtCool series. ArtCool is written on its cover. This is an LG non-inverter air conditioner. The problem with this air conditioner is when electricity is passed through it, the fuse starts to burn immediately. I will remove this circuit board and find out why the circuit board is blowing the fuse repeatedly. I have removed the circuit board from the air conditioner. This circuit board is in two parts. One is a power circuit, and the other is a control board. The microcontroller is mounted on the control board. The fuse is installed in the power circuit. The SMPS or something else is bad in this circuit board, which is the reason the fuse blows. This is the line terminal, and this other terminal is for the neutral connection. From here, one connector terminal is going out for the compressor. This second point is the neutral common connection. Both these connections move towards the outdoor unit. If I take a look at the ZNR, which is used to protect the circuit from overvoltages or the surge. But it seems to be okay. So, I will have to find what component in the circuit board could be physically damaged that could cause this problem in the circuit board. I will have to check it with the multimeter now because I could not find any issue with the circuit board with the physical components. I will now start testing the circuit board with a multimeter. To do so, we will have to understand how this circuit board works. As I told you, this is the line terminal and this is the neutral terminal in this circuit board. I will turn the circuit to see from the other side. This neutral print is connected with this point here and the other over here. Then, both of these prints are moving towards this bridge rectifier. I will check the circuit board and most importantly, the bridge rectifier. I will check whether it has any problem in it. If the bridge rectifier is bad, the fuse blows due to it. I am testing the bridge rectifier. It shows no voltage drop on this side of the bridge rectifier pins. I have changed the polarity now. The voltage drop on this pin is fine. Okay, with this pin as well. Okay, with this pin, too. The bridge rectifier of this circuit board is fine. Now, if the bridge rectifier is fine, what component makes the fuse blow up? If I look carefully at the bridge rectifier, a diode is mounted with it. I will check this diode to see whether it is fine or bad. When the electricity is converted to DC, then it passes from this diode towards the NTC sensor. I will place the multimeter probes on the diode. It is showing 0 voltage drop on the diode. When the diode shows 0 voltage drop, it means the diode is short-circuited. On changing the probe sides, it still shows 0 voltage drop. I have replaced the diode with a new one. I will now test the circuit board. I will power the circuit by passing electricity through it. I heard the beep from the circuit board. I will turn it on with the remote control. The display has been turned on, and the relay has also power on. I will check the output through the tester. And yes, the relay has allowed the output to pass through. Now, off the camera, after installing the circuit board, the fuse has again burst. I will now have to check what other things in the air conditioner are short-circuited. This is a non-inverter unit. In this unit, we can get only a couple of things. DC blower motor is installed in it. Let me show you by removing it from the air conditioner. The second, an ion generator, is installed. I have removed its connection from the circuit board. I will check whether it is short-circuited or not. The rest of the components in this air conditioner are DC operated, like the 12-volt motor, which is installed on the low-voltage side of the circuit board. These motor connectors are installed on the high-voltage side of the circuit. I have removed the connectors of the DC blower motor from the circuit board. The blue and white connectors on the circuit board are for the blower motors. I have removed the ion generator from the circuit board. Rest in this air conditioner. There is no such thing that could be short-circuited. It could be the relay in the circuit board, but it's working. I have replaced its fuse again with a new one. I have turned on the display with the remote control. The relay has also powered on. This means the circuit board is fine. Now, any single or both motors could also be short-circuited. The ion generator could also be shorted. We will have to check what is the issue. Now, this is what I did. I connected the motor with the blue connector in the circuit board. I will check which motor is problematic. It is not a big deal if the ion generator is not installed in the system, but without the blower motor, the air conditioner cannot blow cold air. I will now power the circuit board. You saw that the fuse in the circuit board has blown out. When I remove the motor connector from the circuit board, then the circuit board works fine. I have tried out the ion generator. It has no problem with it. I will test the other motor in the circuit as well. I have added a new fuse to the circuit board. I will check whether the circuit is working fine by turning it on once, and then I will attach the blower connector to it. Yes, the circuit board is turning on. The display is working. I will now connect the second motor connector to the circuit board. I have powered on the circuit board. Here we go. The fuse has blown again. This means both the blower motors of this air conditioner are malfunctioning. I have removed all the screws from the evaporator. I will remove the evaporator from the top so you can see how the blower motors are placed in this air conditioner. Both the motors are placed separately. The half airflow is blown out by this blower, and the half airflow is thrown out by this blower. I will now remove these motors from the air conditioner. To remove these motors further, I will have to unscrew these screws. I have now removed the blower motor from the air conditioner. This is its motor placed in it, something like this. I will remove this nut from the top to separate the blower and the motor. The blades have been separated. This is the other part of the motor. When I rotate the shaft of the motor, it is jammed. When I was spinning the motor with its blades, it seemed like it was rotating smoothly. But when I am rotating the shaft with my hand, it does not rotate easily. It has heated up too. I have removed the second blower motor, and I will open it as well. The nut on this blower motor is quite hard to open. The nut is not coming out of the bolt. I think I will have to cut it. I have made a cut in it. It will now easily come out. This second motor is also jammed, and the previous motor I removed was also jammed. The circuit board of these blower motors is in front. This blower motor has been blown up. When I remove this piece, this is its IPM. The IPM has been completely damaged. The other blower motor is also in the same situation, but less than the previous motor. Whatever it is, it has been blown. I will dispose off these blower motors because they can't be repaired. I will install new blower motors for this air conditioner. If I get time, I will make a video on it as well. If you are willing to support the channel, you can buy me coffee. For that, visit Patreon. Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.